Welcome, or hopefully welcome back to the Reliability Matters podcast. For those of you who are counting, this is episode number 156. On today's episode, we're turning our focus to a pivotal innovation that's transformed design and manufacturing processes. What is that? Flexible circuits. Flexible circuits have emerged as a game changer in the manufacturing and design of electronic assemblies. With their unique ability to bend, twist, and conform to complex shapes, they offer unparalleled advantages in applications where space is at a premium and reliability is paramount. From wearable technology and medical devices to aerospace systems and consumer electronics, the use of flexible circuits has expanded rapidly, bringing with it both opportunities and challenges. In this episode, we'll explore the evolution of flexible circuit technology, discussing its key benefits, such as lightweight construction, enhanced durability, and improved design freedom. We'll also touch on the manufacturing complexities, material considerations, and the critical role that process control plays in ensuring reliability and performance. My guest today to help explain all this is Joseph Fjelstad. Joe is the founder of Verdant Electronics. Joe's been active in electronics manufacturing since 1972 in various roles, including as a chemist, process engineer, and R&D manager. He holds nearly, get this, 190 U.S. patents and numerous foreign ones. He is an internationally recognized expert, inventor, and lecturer in the field of electronics interconnection technology and a veteran of several startup companies, including Beta Phase, Elf Technologies, MetaRAM, Silicon Pipe, Teresa, which is now the public company Xperi. Some of Joe's innovative devices and novel reliability-improving IC packaging structural features are found in nearly every electronic device made today. He's also an author, co-author, or editor of many books on interconnection technology, including Flexible Circuit Technology, 4th edition, the most widely distributed reference book on the topic, Chip-Scale Packaging for Modern Electronics, and Solderless Assembly for Electronics, the SAFE approach. In addition, Joe has written hundreds of articles, columns, and commentaries for various industry magazines and journals over the last 5 decades. And today, he is my guest on the show. So sit back, relax, and join us as we unravel the world of flexible circuits and discover how they're reshaping the landscape of modern electronic design. I'll be back with Joe in just a moment. Stick around.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
5 decades. That's a lot. Does that just hit you once in a while? 5 decades?
Yeah, every now and then. I say I just turned 75. And, 75th trip around the sun. And it does kind of think, well, the average age for men is going to be something like 78. So I got 3 more years. I'll make the best of them. We never know. I think you know Harvey Miller, right? Harvey he'll be 102 later this month. And he's been a personal hero for many decades.
Yeah. So you're a youngster compared to him.
Right.
Yes. It's funny how the older we get, the more we redefine what old means. When I was in my 20s, 40 was ancient. And then you hit 40 and then you're like, well, it's probably 60. And, I'm 64, so I'm thinking 80-something is old. And I'm sure if I'm fortunate enough to reach 80-something, it'll be 100. I'll start citing your friend or George Burns or, someone like that was sharp and productive into their hundreds. But
yeah, well, Harvey's still really sharp. There's no question.
Time will tell. Well, thanks, Joe, for agreeing to come on this show and talk about something you're intimately familiar with, and that's flex circuits. I appreciate you being here. Let's start at the very beginning. I don't like to assume that all of my audience knows everything that we're going to be talking about. So I kind of like to take the we'll start off with the kindergarten version, and then we'll kind of get a little deeper. So for the benefit of the 6 or 7 listeners or viewers that may not have heard of flex circuits before, I can understand why, because we call, electronics are built on the principle of circuit boards, and the word board implies rigid, right? But obviously not all boards are rigid. And, if we take the word board not so literally, then circuit assemblies don't have to be rigid. So can you give just a brief overview on what are flexible circuits and how are they different from traditional rigid circuit boards? I think that's an obvious answer. It's probably the easiest question you've had all year, but let's start with that.
Yeah, I think how shall I say, genealogically, they basically have a parallel path, and arguably, it's work that was done by Ken Gilio. Dr. Ken Gilio was familiar to, I'm sure, a lot of people, where he was kind of tracking the history of printed circuit technology, and he discovered a patent written by a German, Albert Hansen, in 1903, and fundamentally it was using what looks like flexible circuits to use for early telephony for building switch systems, but they were using, basically flat conductors on paraffin paper. And they even had one instance where it looked like it was a multi-layer circuit. So a very, very clever fellow, ahead of his game. So we can go back there, and then there have been a number of people that have followed in the footsteps. So flex circuits early on was the story of Frank Sprague, who worked for, later of Sprague Electric fame, who worked for Thomas Edison. And the story goes is that he asked Edison is the boss chemist, how might he put conductors on paper, and Edison said, well, here's a few things you can think about. One, we could put a pattern, stencil a pattern onto a piece of paper, and then dust it with graphite or metal powders, and then shake off the excess, and we would wind up with a circuit pattern on it.
Much like children apply glitter, for Christmas decorations, right? They just put a little glue down and sprinkle the glitter on it.
Yeah, it's funny how those things get, what informs us, our experiences, the things that we play with, and we just need to be attentive to it. You mentioned children. I always say, we are, as children, the most creative beings on the planet, and then, our education too often, drives it out of us. So that we're not, there's one right answer kind of thing. And you got to love the kids. I'm watching it with my grandkids right now, and they're doing great things. Funny thing, my eldest has just turned 31, so grandchild. So.
Yeah. I also host a podcast on the subject of entrepreneurship, and I talk to a lot of entrepreneurs who started a company, from nothing. And one thing a lot of them have in common is this sense of naivety, maybe even arrogance, meaning they don't know that business is so dangerous. They don't know they can't do something, and therefore they do. And you're right. Education and experience drives certain things out of us. I know at one point in my business when I took a step back and kind of handed the keys to my team to run the day-to-day. I was like a gargoyle, perched on the top of a building looking down, and my team would come up to me from time to time and say, hey, we have this idea. And before they can even finish their sentence, I'm like, no, we tried that 8 years ago. It doesn't work. And I would attempt to kill it. And then I, through advice from mentors and coaches and things like that, I decided, okay, I'm going to stay quiet. I know that's a horrible idea. I know it doesn't work. And it would work because they didn't know it couldn't. And the other interesting thing too is, you mentioned one of the earliest, quote unquote, circuits or boards was probably printed on something like paper or parchment or something similar. It was a flex circuit. It's amazing how many what we think are new inventions are not new inventions. I think of the automobile, the electric car specifically. Way before internal combustion engines came out, all vehicles at the time were electric. This is not new. The technology that makes it possible is new, but the basic idea was the genesis of the automobile, and now we're rediscovering it all over again. And I'm sure there's a million examples like that, not just in electronics, but in everything.
I smiled when you were talking about Naivety, is that back in the late 70s, when I was working at Boeing, Electronic Support Division in East Field in Seattle, I worked in a manufacturing technology group where I had the internet was in my office. There were basically, the old style bullpen of engineers, three desks across, 8 rows deep, and all of the talent that we could possibly ask for was in that room. So you just no more than ask the question and there was an answer. But when we had new engineers, and I was still, pretty much wet behind the ears, when new engineers would graduate from college and come in, and I would take them aside as a seasoned old guy, not really. I am working with World War II vets, so these guys were my dad.
You were the youngster in the group.
Exactly. But I told them, I'd take them aside and I said, you got a huge advantage over the rest of us right now. They'd look at me kind of quizzically and I say, you still have your naivety. You're going to walk around and you're going to look at what we're doing and you're going to be asking questions about why are you doing that? Most of the time, we'll have a pretty good answer, but it's the times that we don't. Those are the ones that we want to mine. So don't be afraid to ask questions.
Yeah. As soon as the answer is because we always have.
Yes.
As soon as the answer to why are we doing it this way is, well, that's the way we've always done it. That's an opening right there to consider the possibilities. What are some of the main advantages of flex circuits in electronic design and manufacturing?
Well, in your introduction, you kind of touched on a lot of them. Mm-hmm. It's the things that are obvious. They will save you weight. They will save you cost. I mean, the ability, the way we can build them is fascinating. I was asked to give a talk at a graphics art industry several years, I guess it's been 10 years, 12 years ago. And in my run-up to it, I was doing a little background. And I said, the printing technology, humans have been using printed technology since 35,000 BC. We have evidence of it on cave walls.
Yep.
And we were doing 2 different types of printing. We were doing stencil printing and we were doing transfer printing, where you dip your hand in a pigment and then put it on a wall. And the other one was put your hand up against the wall and spray the pigment from your mouth over the outline of your hand. And so those 2 technologies are still in play today. And so that printing aspect of it, printing on something simple and thin. In fact, I was just reading today, just this morning, bumped into another, it's timely, but invention out of Japan. We're using indium gallium materials, and then they called it bubble printing. And they were basically using a laser on this material to cause it to melt instantly and become a flexible ink, and or a stretchable ink, because that's another aspect of flexible circuits, which is really becoming important, is stretchable, especially for the wearables and medical products. So,
yeah, on that subject, I had Dr. Michael Dickey, who's a professor at North Carolina State University, on my show a couple of years ago. And he's evidently one of the leading researchers on a particular gallium alloy. Gallium, of course, is at room temperature liquid. Yeah. And much like mercury, only less toxic. And he figured out he can add a couple of ingredients to it. And then if you charge it with a small amount of electrical current, it solidifies, it becomes solid instantly. And then remove the current, it's liquid again. And he was able to come up with, by putting the gallium in a silicone tube, basically, he was able to allow it to be flexible, and then when needed, instantly become solid in that flexible shape. And then if needed again, remove the current, and now it's movable. So it had the advantage of a rigid circuit and a flexible circuit, kind of all in one. It seems fascinating. I'm not sure how much of our industry, besides, a really cool parlor trick, I'm sure it has legitimate applications. I just haven't seen that yet, but I'm sure it will come.
Yeah. Well, that's one of those things, that's phase change activity being, applied with it. I had a good friend of mine, John Crummy, was at Raychem when I first met. No, actually, I met him just after, but he was also the founder of Metcal. You're familiar with?
Yeah, sure.
With solving ions, but he made a career out of nitinol, and so he's done amazing things. And I worked with him on the beta phase connection. We built back at that time using a flex circuit. I think the number, and I could be off, but it was something like 500 IO per linear inch controlled impedance connector for the Cray T90. And, I think I'm not certain that it's not still the high water mark for density for a connector, but it was a separable connector. And he liked the idea of the flex circuit. And that's how I got engaged with his activities. But, it's that you're just one of the most creative people I've ever had the pleasure to know. And I'm going to actually go see. He lives not too far from me now. He's back up from the Bay Area. I'm pop over and see him tomorrow. It's been too long. So,
when I think of flex circuits, they do flex. And most of my experience with flex circuits is they flex until you plug them into place, and then they never have to flex again. I'm talking about a connector in a PC or a Mac or something, right? And it's the easiest way to route a connector that will eventually mount to a board. But the connector is up here, the board is down here, so they just use a flexible connector. Are there applications in the flex world where they flex regularly as part of the application, or does fatigue and other things, is that the fly in the ointment that they can't flex too many times?
As I point out when I used to give regularly my flex circuit webinars or seminars at various locations, I did record a series of talks for my friends at iConnect 007 several years ago. And so those are around and available. But I pointed out that, yes, as you mentioned, the vast majority of flexible circuit applications are static. They're designed to be flexed to fit, and then we're done. We're that transition in 3D space so we can make, viable connections often, and with some other requirements for controlled impedance or the like. But there's the subtleties that we've learned over time of there's flexing and there's flexing. Vibration, is high frequency, low amplitude, but it's still flexing. Mm-hmm. And so we'd like to think of, something like a disk drive where they used to use the read-write heads go through millions or billions of cycles, and so you have to design them for that with that intent. But a lot of times, shock and vibration are the things that are going to take you out. If you look at an automobile or an aircraft or the rest of it, they're not, and failures caused by that. That's the thing that's been interesting, is the discovery of failures and going, well, what happened? And you find out that, oops, we weren't paying attention to that. And it's like the torsion bar on an automobile,
right?
It goes through bazillions of cycles before they fail. But that's the kind of lessons that
ultimately they do have a life, right? They can only have so many flexes in their lifespan.
Yeah, everything fails at some point in time. And, but I attended Phil Crosby's quality college, back in the 80s. And, quality is basically, fitness for use, is that it has for the for the desired lifetime of the owner. Does it, in some cases, if it's a launch vehicle, it's going to get used once and just has to hand on to that,
Sure.
So,
So what industries historically have benefited from flex technology, and what maybe emerging applications do you see coming down the road for flex? And I'm thinking a lot, I'm thinking IoT is driving a lot of that, wearables and things like that. But what are some other examples of traditional applications and maybe less traditional applications?
yeah, well, as I mentioned, the disk drive industry, which was a big one. And disk drives have been, they're still used. That little read-write head, which goes through, millions to billions of cycles over its lifetime. Wire, places where it's been wire harnesses, with the early printers, the transference of the print head back and forth across the carriage. I say you ask the question, and I start thinking of way too many applications. But that there are any time that in a lot of cases, it's a replacement. I've worked with people where they were trying to do, and this cuts both ways, by the way, is that people would come and would say, well, I've got a bunch of these little wires here that I want to connect, and it's a pain in the rear end to have to wire them all. Can we build a flexible circuit for this? Sure. Yeah, we can do that. No problem. And put headers at both ends so that they can all be connected exactly as they're supposed to be. But the alternative is occasionally is that, people want to build something very complex. And we actually did it. I worked on the land wire project at Pacific Consultants back in 1999. And, we had this soldier of the future where, he's, complete computer, heads up display, gun sight display, GPS, ability to differentiate friend from foe in a field of battle, and eliminating, fratricide, which has been a big problem in every war. And so, it's a really, really great design, and they've actually reduced it to practice. But I had another friend who I was working with on that team. He wanted to build a flexible circuit, kind of harness for monitoring, health of seniors in a care environment, and then be able to put this electronic system on it so they could move. And I said to him, no, Bob, you really don't want to use a flexible circuit here. You just want to use discrete wires because it's going to be easier and cheaper to build. And that's the way a lot of those things are happening now. Now, it should probably, or could be probably, reinvestigated today with what's going on in the conductive materials, which they've got standards around now, trying to build circuits directly on fabric and for wearables.
Mm-hmm.
And so, it's the limits are really in imagination, and I continue to be fascinated. I had a chance to visit NextFlex when they first popped on the scene, I guess about 10 years ago. And, they were, how shall I say, hired, so to speak, by the most, got funding from the government, military primarily, because the military has long been, or the forge of war has long been a place where innovation happens. It's just the way it is, But
That's where necessity meets innovation.
Yeah. I say the first volume production of printed circuits, was in late World War II, and it was proximity fuses for mortar shells. So, again, the forge of war.
Yeah.
But those then have practical applications as we start to look at them again. with new sites. It's understanding, how the invention can be reapplied. You look at it and see where did it work? How did it work? How might I use that somewhere else? And that's the fun part of this industry. I think it's interesting for me. Again, I've kind of followed Ken Gillio's lead on a lot of things and look into the history of what we've done. The integrated circuit, we all know, was invented by Jack Kilby.
Yep.
But what most people don't know is that Jack Kilby worked at Centralab in Milwaukee, Wisconsin, before he went to TI. And at Centralab, they were making what? Printed circuits, stenciling circuits onto. So when he was presented with this transistor concept, he thought, oh, well, I can interconnect these transistors with, wires. And he cobbled it together. We've all seen the picture of it.
Sure.
And it worked. And I say, I like to think, hopefully, I don't know, but that I'd like to think that if I had all of his experience and knowledge, or anyone who might have had all of his experience and knowledge, a good engineer might have come up to the same answer. And of course, Noyce and Henri figured out how to do the planar process, which, is what we're still into today.
Today, yeah.
But it's been a real interesting ride.
I would think that one of the obstacles to flex circuits back in the day was the size of components. I mean, they had rather large form factors, particularly in the through-hole days. And, things between the components can flex, but the components didn't sign up for the flex army. They're pretty rigid. I would think that miniaturization, as we've all witnessed in this industry over the last 10, 20 years, and even since we started this broadcast today, I'm sure something's just gotten smaller, has led to kind of the greater possibilities within the flex world, because now components are so small that more of the total circuit is flexible than it was back in axial leaded component days and transistors and things like that, TO cans and things like that are large and they don't flex. Now that we have very small components where we could put hundreds of them on our fingernail, if not more, that I'm assuming allows a greater benefit to flex circuits and greater possibilities within that technology.
Yes, very much so. In fact, what's, over the last 10 years or so, the ability to do backgrinding and thinning of silicon, everything is flexible if you make it thin enough, including glass and silicon.
Sure.
So the ability to make things really thinner. But I just think back to something else as I included it, I think, in my book. There was an article I discovered that was in an old, I think it was Popular Science magazine from November of '68, that it said, now they're printing transistors on paper. So in other words, that, they were actually printing, transistors. They were crude, big, and not particularly efficient, but by God, they were doing it. And so we laid those kinds of foundations. And then, of course, if you make things really small, then, you can place them, and the stresses proximate to them are small, so that those, so those things are going to be, or should be, just fine. To that end, real quick, I have some friend of mine at Dr. Jana Sheets at Terrace Circuits, and her company is developing a technology for being able to handle and place it, down to 50 micron or 50 nanometer, 50 micron. I'm trying to think, it's extremely small. Is what will be used for the micro LEDs. And place them. So it's basically be able to components on a glass plate, affix them, and be able to release them one at a time from the glass plate wherever you want them. So it's like
Fascinating. Yeah.
oh God, yeah. So that's again, it's just being proximate to really smart people. It's really entertaining. So
You mentioned popular science, 1964 popular science. I have a beef with popular science because I was a popular science nerd, when I was a kid. And I got two magazines when I was a kid, a Highlights magazine and a Popular Science magazine. And
okay,
I don't think I could even understand all the words that were in it, but they owe us one thing. They said by the year 2000 we would have flying cars, and pretty much everything else has come to fruition, but I'm still waiting for the flying cars.
Well, we had flying cars in the 50s and 60s. The only problem is they're not particularly practical.
That's true. But I always thought by the year 2000, everything was, but 2000 was so far away when I was a kid that I thought it was going to be kind of like a Jetsons lifestyle,
exactly.
right? Floating restaurants in the air and things like that. And we'd take our flying car up there. But alas, that didn't happen.
We can get.
Exactly. I'm happy with the state of progress that we've made.
Yeah.
I think we live in a fascinating time. What are some of the common challenges encountered when designing and manufacturing flexible circuits, and how can these challenges be mitigated?
Yeah,
or how are they mitigated?
Yeah, I've said again, in lectures, has come to the conclusion is the understanding is that you have to wear two hats when you're designing with flex. Is you have to understand, your electronic concerns and your mechanical concerns. Is that how these things are going to be used? Is that the dynamics? But what we're asking of flexible circuits is a lot more than we ask for rigid boards. They're back to the idea of being able to use them once and then you're done. So handling them in manufacturing becomes really problematic as opposed to handling a rigid board. So we need to fixture differently on the manufacturing and the assembly side. There are some interesting materials that have been developed over the years, for example, on the assembly where you can actually, this is, akin to what I was talking about terror circuits, is that notion of a material that will hold and then release. And then how do you get it to release? A lot of things are heat release and they pop off. But so from an assembly standpoint, you want it to be flat and you want it to be stable, and so there have been materials that have been developed that people put them on carriers and the like.
Yeah.
So the other thing is, again, is back to the rules, and there are rule books, there are design standards, the IPC has them, and those should be read and studied. But that said, as I wrote in a column, probably a year or two ago, maybe three now, is said, they talk about all the DF things that we have, design for excellence, design for test, design for whatever. And I think I said in my article, I said, we need to, don't need to throw it away, the design for, but we need to add another design, and it's the design W. And it's specifically design with manufacturing, design with the people that are going to make the product. I did a lot of interface with people who came in the door with an Escher drawing, and they'd say, "I'd like this rendered in 3 dimensions, please." And you go, that's going to be really not easy, but let's talk. And so that notion of being able to talk through the problem with the designer, and so, you're going to have to go to the prom with somebody. So you better get to know them beforehand and spend as much time as you can learning about and from them. And they're going to teach you how to dance.
Yeah, I think one of the, you bring up a great point. I think one of the things I've talked about on this show before is how siloed our industry is. I look at all the different elements of our industry. So board design, board fabrication, assembly, box build, et cetera. And we are like villages along the same river, but we don't know who they are upstream or downstream, and we don't really care. I think most assemblers believe that boards are delivered by storks, and they just fall on parachutes into the receiving bay of the company. And I think that board fabricators don't understand what are the designers smoking when they send the Gerbers over or whatever. It's like we can't build this, and the assemblers feel the same way. So I do think that I love the DW.
Yeah.
Fill in the acronym. Design with. If the assemblers were at the table when BGAs first came out, then we would have saved about 10 years of conference material trying to figure out how to mount, how to inspect, how to clean BGAs. And same thing with surface mount. And in our industry, of course, it's probably good for the conference world, because in our industry, we're given a new part and without instructions. And it's like, okay, yeah, here it is. Here's a BGA, or here's a surface mount component. And we're like, where are the leads? Where are the holes? What are we supposed to do with this? And then we spend years in conferences talking about best practice ways to do it. And I think right now we're witnessing that with ultra high density interconnects, where it's like, I can't even see this stuff. And that's landing in the flex world too, UHDI, right? These are interconnects. They tend to be flexible and highly miniaturized. So we're seeing that now. We're seeing, I work a lot with SMTA. I'm on the board there. And we have a new conference. This is, in fact, it's coming up in January in Arizona, the Ultra HDI conference. And it's kind of on that subject. It's like, what is it? And what are its benefits? And how do we use it? How do we make it? How do we test it? How do we clean it? All the different how-to things are now being discussed because they're here. And Asia's been making them for a long time. Japan, I think, mostly has been making them for a long time. And now we're trying to figure out how to, match it or beat it. And it creates an instant product without an instant understanding of the product and all of the implications, that brings.
Yeah, I muse on occasion about the fact that, when I entered I mused on paper not too long ago in an article that I purchased my first integrated circuit with about 3 months of savings from my paper route in 1957. And that was in 1958 is when Jack Kilby invented the integrated circuit. So the integrated circuit in my case was a 6-transistor radio, 6 transistors mounted on a paper phenolic board. And so, if you think about it, if you parse the problem and start to think about it, it's an integrated circuit. The integration of vacuum tubes before that was an integrated circuit. A bunch of little switches that were all operating and wired, often interconnected by discrete wires, with little plug-in components. My old, had a vacuum tube television perhaps at one point in time in their life. So
my dad used to send me to my favorite chore, so to speak, to do for my father was to go to Radio Shack and test the tubes.
Yes.
The TV wasn't working, so he'd pull out every tube and send me. I felt like Captain Kirk, like I was on the bridge of the Enterprise, with some console, and that was so much fun to test the tubes and watch the needle move or whatever, light turn on or whatever it was.
Find the bad one.
Find the bad one, yeah.
And pitch it. Yeah. No, same thing. I did that as well. My dad was a brilliant engineer, so I was a go-to or go for, for him as well.
Yeah.
And, learn a lot that way.
what's changed? I mean, from the day in 1903 when it's believed that the first circuit was probably printed on paper. What's changed in flexible circuits over the years? What are some of the major technological milestones?
Well, the things that you mentioned early on, the feature sizes have certainly been shrinking, getting smaller and smaller. The materials have changed measurably over the years, and in terms of their dielectric constants, their temperature capabilities, their cost, their structure, their thickness, their how we might process them, rather as sheets or in reel-to-reel. It's one of the things that has happened, learning how to build them reel-to-reel. That was, by the way, one of my other instantiations as I spoke. We at a company called Elf Technologies, which I wasn't a founder, but there were three fellows out of Raychem whom I was asked to consult for, and we sat down, and they had this technology that was part of one of the founders' PhD thesis at Aarhus University in Denmark. And he was thinking, we can take a Xerox machine, a laser printer, and use toner, and that you can actually build the toner, turn it into a catalytic toner, and then take that catalytic
and then fuse
toner,
it, right?
You fuse it, and then you can fuse it. We wound up fusing it onto polyimide films, but we could also do it on paper again. But the trick is then to electrolytically and electrolytically copy it. Now, we got a fair amount of funding on it. It was frustrating that at that time, I mean, I had great affection for my colleagues, but they just kept on wanting to play and then perfect. I said, we can make money now. We could have a manufacturing operation that would be run by the customer. In other words, send in your drawing, your data, and we'll run it through the machine and have the machine running constantly so that you can be producing circuits reel to reel. And the nice thing is that you could actually produce an economical run unit of one, drop it in the middle of production run, and then build a circuit of extended length flakes, hex. That was, hence the name of the company was Extended Length Flakes. But, the thing is that they were originally saying, we want to, print interlayers for printed circuits. And I said, tell me more, but no, you don't. You want to make flexible circuits, and you want to make them really long. And so got them funded, but as I said, it was a frustration for me so I stayed for a year or two, and then a friend of mine, we probably know Paul Benke. Paul called me up and said, "Hey, Joe, how'd you like to go live and work in the Soviet Union?" I said, "When do I leave?" So I got there just as the wheels were falling off. I would say I went to work in the Soviet Union, and when I left, it was Russia, but I don't get to take any credit. So
that's between Reagan and Gorbachev. It had nothing to do with Joe, huh?
Exactly.
It's amazing how fast time flies when we're having these conversations. So I'm going to do some rapid fire questions for you, so we can get through some of the list here. You mentioned polyimide. Is that primarily still the material of choice on flex circuits, or has that changed into something else, or is there something else coming?
No, it's typically still polyimide. It's been there. It has all the right attributes in terms of temperature, dimensional stability, and the ability to process it. We're well schooled with it, so don't change certain things if they're working.
Yeah,
there have been some new things, and one of the things I want to say real quick before I change is that I mentioned glass. Glass is really thin. It's flexible, and glass is coming for certainly in the packaging world. Glasses are important, but I also, again, when I used to give talks, is that you want the most flexible circuit possible. It's air, and so the idea of air being able to transfer information across air, that's a really flexible circuit. The connection.
Well, we have inductive chargers now, which some of the better ones can have a little bit of distance, between the charging base and the receiving instrument. And we have RFID,
Yes.
which is a great
Yes.
technology. We have toll roads here in Southern California, which for reasons I don't understand, because our car registrations are much higher than the rest of the world. And they used to say, yeah, but we don't have toll roads. And now we have both high registration and toll roads. But the original days of the toll roads, not too long ago, we had this big battery operated block we had to Velcro to our windshield. And it was a RF, right? It just, sent a frequency up. And now we have a little tiny clear sticker, with a small little circuit on it. And it's RFID. And the receivers are higher than the tallest truck that could drive underneath it.
Yes.
So they're 35, 40 feet in the air. And people are going through it, 80, 90 miles an hour, and it's capturing it through the air. And so, yeah, we're there, just not in the way like, you and I can't have this conversation outside of, Wi-Fi technology or something that's sending data through the air. But we're not. You're right, though. I mean, air is the ultimate dielectric, right?
Yeah.
Thankfully. Yeah.
Dielectric constant of 1. So,
Yeah.
perfect.
When it comes to testing and inspection of rigid boards, we all know how to do that. There's lots of technologies to do that, AOI and SPI, in the earlier stage of production. Is there a different testing protocol and inspection protocol when it comes to flex circuits, or is it the same but different?
I mean, I am, I had the good fortune to listen to Deming talk once upon a time. And,
Wow.
He talked about, test 100% or none. In other words, that testing is great in development, learning what you're doing. But the trick is that testing really, it's an education tool, but it shouldn't be a production tool. You need to learn how to do it right. In fact, I was giving a talk at an aerospace conference, and I heard myself say at the end of my talk, I said, first we need to do the right things, and then we need to do those things right. And I don't know if I'm the first person to ever say it, probably not. Probably not the first to ever think it, but it was one of those things where it just makes absolute sense. Testing doesn't add value. Testing costs money, a lot of times a lot of money and time. So the trick is to use testing as an investigative tool and then figure out what and how to process, how might we process so that we don't have to test. And that the ultimate test is turn it on. Did it work? That great, goes in good pile.
Right.
I think a lot of handset makers do exactly that because it's too hard to test.
Like the old adage, we don't have time to do it right, but we'll find the time to do it over.
Bingo.
Yeah. Get out your crystal ball, Joe. What's the future of flex? And short of, well, maybe not short of, maybe including air circuits, but outside of air circuits, where do you see flex going?
I think that it's just, I gave a talk at one of the keynotes at the first Stretchable circuits conference in Europe and Belgium, probably 13, 14 years ago. And, the stretchable aspect of things is where we're seeing a lot of attention being given to it. And so I think we're going to see more. I don't know where it ends. That's the problem. What I continue to be amazed by is how clever and unbounded we are, is that we're smart collectively. We're really smart. And we do ridiculous things. And it's so as long, I've said on more than one occasion to friends and colleagues, I said, if you see somebody walking on the ceiling, don't tell them they can't do it, because it could end up really being disastrous and a missed opportunity, So the things that, if you ask talented engineer if a certain thing can be done, and it's really difficult. We all know that it is. He'll tell you, well, there's this problem, there's that problem, and no, you might want to make a pass. But if you go to that same engineer and say, I heard that somebody's actually doing this, how might they be doing it? And they'll go, oh, well, you might be doing this, I might be doing that.
Right.
Now,
That's a very clever approach. Yeah. It's an alternative question, which dispels it can't be done. Right.
Assert without proof.
Yeah.
And then the mind is no longer blocked, and people will see new ways to do things. I'm fascinated. I'm lucky I grew up as a kid, out in Mojave Desert. My dad worked at Edwards Air Force Base, and I was looking up into the sky and watching the X-planes fly, so the dawn of I had test pilots and engineers in my neighborhood, and I was a pesky little kid who had no interest in my peers. I was
they're not flying planes. Yeah, your peers. No. Yeah, they're on the monkey bars. These
guys were much more interesting, and they tolerated me, which was nice. But I don't know where it goes. I don't have the crystal ball. I have, as you probably know, my own visions of how things ought to be done. I know this, is that if we were to have all the knowledge that we have currently in our heads and in our industry, our collective selves, a priori, and we were to set about doing a greenfield manufacturing operation for circus, a lot of the stuff that we're doing, I'm pretty sure we wouldn't be doing. I've just believed that.
Yeah, I think you're right. Before we leave, tell me a little bit about your company, Verdant Electronics. That's the right.
Verdant Electronics. It's been around.
What does it do?
Well, I said it's fundamentally, it was an epiphany. I don't know if you remember. I was very opposed to. I was originally in favor.
Lead-free.
I was originally in favor of lead-free because I'm an old hippie from the Bay Area, and I'm environmentally conscious.
So from a socially conscious standpoint.
Absolutely. So this makes sense. And then when it started to roll out, I did the science. I just started looking at where, what's the morbidity and mortality rate? What's the real risk here? It isn't there. Even to this day, tin lead solder is just fine. It's not a problem. You can set up some strong methodologies for being able to test it in terms of leach, like using vinegar, and which, I'm sure every landfill is full of vinegar.
Full of vinegar, exactly.
But vinegar will solubilize lead. Everything else, lead sulfate,
water, rainwater won't, for example.
Yes. And lead sulfate, and lead chloride are incredibly insoluble. But lead acetate has another name. It's called lead sugar. And so, it's sweet. And it was used in paints for pigments and leads. And everybody alive who lived near a city in the 70s, 60s and 70s, a major city, was lead toxic by today's standards.
Sure.
So I'm not a proponent of lead per se, but lead in electronics is completely harmless. And there's no demonstrable problem with it.
Well, I think one of the things that I wouldn't say keeps me up at night, but if something was going to keep me up at night, if I was looking for something, I would find this. The military never went lead-free till today. They're still using lead. And, I always find statistics amazing. And remember the ad when I was young, you'll remember this. It was for Dentyne sugarless chewing gum. And the ad said 4 out of 5 dentists recommend Dentyne for their patients who chew gum. I want to know what that one holdout was, right? That, the 25% of dentists do not recommend it. I'm more interested in that than I am the 3/4 that went along with it. I want to know, what do they know? That, they all have the same level of education. They all have the same credential. What are they holding on to? And I find that worth investigation. And when the entire industry says, oh yeah, we're going lead free, but the military, whose the definition of mission critical says not us. Nope. That to me, that's just pause for consideration.
Yeah. Well, to close out on your question, to answer it, which I didn't do yet, but is for me, it came, I fought it because I found that it was less than 0.5% of all lead consumed globally on an annual basis was in electronic solder. And there was no demonstrable morbidity or mortality associated with it. So I said, we don't need this. And I reckoned it, one of my columns, I said it's akin to the, charge of the Light Brigade, was, cannons to the left, cannons to the right, cannons to the front. Was there a man dismayed? Not, though the soldier knew someone had blundered. So the people in the trenches knew this was problematic. But, the generals said that this is what we were going to do, and so we did. So I wrote, I and Harvey, became caricatured as Don Quixote and Sancho Panches, for our, but, we're being proven right by time, but that's okay, So the nut of it is that after all of this protesting of what was going and saying this is nonsense, I was writing columns for circuitry at the time, and I started to write my column, and I wrote down 3 words, just typed out 3 words, assembly without solder. And I went, bingo, that's it, that's the answer. It's how do you build without solder? And the trick is to say, you build a component board, and then you put solder, put the connections on it. Build component board and apply the circuits, build up the circuits on the terminations. It would have worked really wonderful if I'd have come up with it in 1984 before.
As an alternative to switching alloys.
Yeah.
Well, get rid of the alloy.
The early surface mount industry was perfect for it. The only problem was that we had now we have thousands of different lead patterns, lead types and patterns. We don't need them. We only needed land grid arrays and LGAs, or LGAs and 2FNs. And if you use those, it could be really beautiful in terms of, and then the trick is to essentially engineer the materials around them and the buildup, and it becomes really simple. So that is the essence of Verdant. And I sent what I called a green paper to Werner Engelmeyer, whom I'd known for many years before that. And I sent him what I was proposing doing. And Werner sent me a note back. He said, Joe, you're going to put me out of business. I said, no, Werner, I'm going to put you into a new business.
Right.
And so, 17 years later, I'm still pushing that rope. But, we're getting some traction and working with Ray Rasmussen and Nilesh Nayak and Dana Korf, whom you might know. By the way, Dana said, take Gerber out of our lexicon. It's a horrible solution, and it doesn't work today. So we need to remove it from it.
And yet it's still here, right? It's still ubiquitous. And speaking of Ray Rasmussen and yourself, we are going to be back on this show. Both of you will be on this show soon to talk about solderless technologies and
good.
And where we are on that.
Yeah, Ray's a godsend for me. I'm not, you talk about entrepreneur. I'm kind of the quintessential non-entrepreneur. I work on ideas and then, I don't pursue the money. It's not, it's like a lot of things. Things that I invented at Silicon Pipe 20 years ago are just now starting to show up in product.
Wow.
And
that must feel good after all those years.
Well, it is, as you're right. So in other words, I don't discount my tuition and my intuitions. Yeah. I'm saying, that the ideas are there. Just need to wait for, things to catch up. So I'm hopeful. Feel a little bit at times like Moses, where you get a chance to look into the promised land. Might not live to make your way.
Might not go down into the valley, but you're seeing it from a high, right?
But you can see it. And so the hope is there. And I'd say that there have been enough people that have, given me encouragement over the years. Say the trick is to not give up.
Right.
When you give up.
Persistence. You're more of an entrepreneur than you give yourself credit for, because that's one of the hallmarks of any entrepreneurs that's been ultimately successful is persistence in the face of challenges, right?
I thought you were going to say insanity. But...
Well, that too. And you got to be a little crazy. You got to be a little nuts. But you're a child of the Bay Area. I'm a child of the Bay Area. I was born in Berkeley and raised in the East Bay and used to terrorize the city. People's Republic of, yeah, exactly. So you got to be a little nuts to come out of that region of the world. Are all or most of your books still in publication?
Yeah, so far as I know.
Good.
Again, it's mostly because I've never made, I don't make money on books. For me, it's an imperative to share knowledge. I'm not there for fame. I'm there or wealth or anything. I don't care. I mean, for me, it's about giving things away. It's like, I write my columns. Like you write your column. I'm sure you don't get paid either. We don't get paid.
No, I think the path to financial success is not in what we are doing here. This is a pay it forward thing, and it does lead to success in other measured by another criteria. I think it's a pay it forward, and it comes back in many ways that are unexplainable, right?
Sure.
But it is fruitful. So for my audience who would like to read what our friend Joe has written over the many years of his illustrious career, I'm going to have in the show notes, I'm going to have a list of Joe's books and where to get them. And I'll have some contact information for Joe through his company, Verdant Electronics. And if you'd like to get more information on his company, just look at the show notes. And if you want to find out where to get his books, also look at the show notes. If you're watching this on YouTube, down here, there's a show more area. Just click that and you'll see that information. If you're listening to this on your favorite podcast app, then go to that podcast app, look at the show notes for this episode, which is episode number 156, and you'll be able to see that. Joe, my friend, it's always good to see you. And I'm sorry it's pixel to pixel, but are you coming out to IPC Apex Expo in March of 25?
Yeah, I've been doing that for, God, how many years?
You going to be hanging in the iConnect booth?
Since 78. No, they kind of changed their core, the way they're doing things. That's okay. You run your race.
Well, I will find you, and we'll grab a $20 cup of coffee on the trade show floor.
Or we'll explore more over a pint of beer somewhere.
Even better. Better. Okay, I'm going to hold you to that. All right. Sounds good. Well, Joe, thanks again for being my guest on the show, and thanks for illuminating the world of flex circuits for me and my audience. I really appreciate your wisdom and your willingness to share information. You've always been that kind of guy, and I appreciate you being that kind of guy on this show.
Thank you very much, Mike.
Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. If you're watching this podcast on the Reliability Matters YouTube channel, be sure to like and subscribe to the podcast to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. And a very special thanks to Printed Circuit Engineering Association's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks also for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or episode suggestions to mike@mikeconrad.com. Just remember, that's Conrad spelled with a K. To learn more about the podcast, please visit Reliability Matters Podcast website at, you guessed it, reliabilitymatterspodcast.com. Once again, thanks for listening to or watching the show. Until next time, stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.